1997, hydrophones deep beneath the Pacific Ocean picked up a sound so loud it shook underwater monitoring systems across an entire ocean. This is MrPhantom, and tonight we are going underwater, not to the shallow coastal waters where light still reaches and marine life is familiar and cataloged and understood. We are going to the deep ocean, the part that covers most of our planet, the part that remains, to this day, more unexplored than the surface of Mars. We are going to the place where a sound was recorded in the summer of 1997 that no one could explain, that traveled across thousands of miles of open ocean, that registered on instruments built to detect the movements of Soviet nuclear submarines, and that produced in the scientists who heard it a reaction that is both entirely understandable and deeply revealing about the relationship between human beings and the darkness of deep water. This is the story of the Bloop. To understand why the Bloop mattered, you need to understand the system that detected it, because the hydrophone network that picked up this sound in 1997 was not a scientific instrument in the ordinary sense. It was a weapon of the Cold War. SOSUS stands for Sound Surveillance System. It was conceived and built by the United States Navy beginning in the 1950s, at the height of the Cold War, when the primary strategic threat to American naval dominance was the Soviet submarine fleet. Submarines are invisible on the surface. They cannot be tracked by radar. They cannot be seen from aircraft at depth, but they cannot be silent. Every submarine, no matter how carefully engineered, produces sound. The movement of machinery, the flow of water around the hull, the operation of propulsion systems, all of these generate acoustic signatures that travel through water with remarkable efficiency. Water, it turns out, is an extraordinarily good medium for transmitting sound, far better than air. Under the right conditions, sounds generated in the ocean can travel not hundreds but thousands of miles before dissipating. The Navy knew this, and they exploited it systematically. SOSUS was a network of hydrophones, underwater microphones, installed on the ocean floor at strategic locations across the Atlantic and Pacific Oceans. These hydrophones were positioned to take advantage of a specific acoustic phenomenon called the SOFAR channel. SOFAR stands for Sound Fixing and Ranging. It refers to a layer of water at a specific depth, typically between 600 and 900 meters below the surface, where temperature and pressure conditions create a natural acoustic waveguide. Sound generated in the SOFAR channel does not dissipate in all directions the way surface sound does. Instead, it becomes trapped within the channel and travels horizontally across vast distances with minimal energy loss. The Navy placed their hydrophones at depths corresponding to the SOFAR channel and connected them via undersea cables to shore-based listening stations where analysts monitored the acoustic data around the clock. For decades during the Cold War, SOSUS tracked Soviet submarines with extraordinary precision. The system was classified at the highest levels. Its existence was not publicly acknowledged. The analysts who worked with it did not discuss their work. SOSUS was one of the most significant and least publicly known intelligence assets of the Cold War era. When the Cold War ended and the Soviet submarine threat diminished, the Navy faced a decision about what to do with this extraordinary network of underwater ears. The infrastructure existed, the hydrophones were in place, the cables were connected, the listening stations were operational. Rather than decommission the system, the Navy made it available to civilian scientific agencies. NOAA, the National Oceanic and Atmospheric Administration, gained access to the SOSUS data and began using it not to track submarines but to listen to the ocean itself. What NOAA scientists discovered when they began analyzing the SOSUS data for scientific purposes was that the deep ocean is not silent. It is filled with sound. The grinding of tectonic plates against each other generates low-frequency rumbles that travel through the SOFAR channel for thousands of miles. Underwater volcanoes produce distinctive acoustic signatures. Marine mammals, particularly the great whales, use low-frequency sound for communication across ocean basins, and their calls are clearly audible. So the ocean, listened to through a network designed to detect submarines, turned out to be an extraordinary NOAA scientists began cataloging the sound. They gave informal names. There was there was low, there was ups. Each of the sources: geological events, ice activity, biological sources. The scientists were building a library of deep ocean acoustics, matching sounds to their origins aliens, developing an understanding of what the ocean floor sounds like when you listen to it carefully. And then, in the summer of 1997, they heard something that did not match anything in the library. On the hydrophone arrays distributed across the equatorial and South Pacific in late summer of 1997, NOAA's monitoring systems detected an ultra-low frequency acoustic signal. The signal was not a brief event. It rose in frequency over the course of approximately 1 minute before ending. It had a characteristic shape, a profile that was distinct and unusual, and it was loud, extraordinarily, almost incomprehensibly loud. The signal was detected simultaneously by multiple hydrophone stations, separated by thousands of miles of open ocean. For a sound to be detected across that distance with that clarity, the energy required at the source is enormous. Sound dissipates with distance, even in the efficient acoustic environment of the SOFAR channel. The fact that this signal was registering clearly on sensors thousands of miles from its apparent origin implied a source of acoustic energy that was, by any measure the scientists initially applied, unprecedented. NOAA scientists triangulated the origin of the signal. Using the time differences between when the signal arrived at different hydrophone stations, they could calculate the approximate location of the source. The triangulation pointed to a remote area of the South Pacific Ocean, near the coordinates 50 degrees south, 100 degrees west. This is an area of open ocean, far from any shipping lanes, far from any significant human activity, in one of the most remote and least studied regions of the Pacific. The scientists listened to the recording. At its actual frequency, the sound is below the threshold of human hearing. The human ear cannot detect frequencies as low as the bloop's fundamental frequency. To make it audible, the recording had to be sped up significantly, by a factor of 16 times its actual speed. When sped up and played through speakers, the sound had a quality that was difficult to describe in purely technical terms. It was not a mechanical sound. It did not sound like a geological event in any way that matched the geological sounds already in the library. It had an organic quality, a biological quality. Something about its profile, its shape, its frequency variation over time suggested to the scientists who first heard it that it might be biological in origin. That is, it might have been produced by a living thing. And that is where the problem began. Because nothing known to science, no whale, no marine mammal, no biological organism of any kind identified by marine biology is capable of producing a sound of that frequency and that energy output. The blue whale is the loudest animal on Earth. Its calls are low frequency and extremely powerful, capable of traveling hundreds of miles through the ocean. But a blue whale's acoustic output, while impressive, is orders of magnitude below what would be required to produce a signal detectable across the distances at which the bloop was recorded. For a biological organism to produce the bloop, it would have to be vastly larger and acoustically more powerful than any animal known to exist or ever known to have existed on Earth. The scientists did what scientists do when they encounter something genuinely unexplained. They documented it carefully. They analyzed the data. They compared it to everything in the existing library of deep ocean acoustics, and they concluded formally that they could not identify the source. The bloop was real. The recording was genuine. The data was solid, and no one knew what had made it. The scientists named it the bloop, an informal designation based on the sound's auditory quality when sped up for human hearing. The name was not intended to be dismissive. It was simply the kind of informal naming convention that scientists use for unidentified acoustic phenomena while analysis continues. NOAA did not suppress the information. They published it. They made the recording available. The bloop entered the scientific literature as an unidentified acoustic phenomenon of unknown origin detected in the South Pacific in the summer of 1997. For years, it remained unexplained, and then the internet found it. In the years following 1997, as internet access spread and online communities began forming around shared interests, the bloop recording circulated widely. People listened to the sped-up version and reacted to it the way human beings have always reacted to sounds from the deep ocean, with a primal, visceral unease that is difficult to articulate but impossible to ignore. There is something about the idea of a sound from the deep ocean that triggers a fear response in human beings that is disproportionate to the abstract information being conveyed. This is not irrational. It reflects something true about our relationship with the deep ocean. Human beings evolved on land. We are terrestrial animals. The ocean, particularly the deep ocean, is an environment to which we are fundamentally alien. We cannot breathe there. We cannot see effectively there. We cannot survive there without extraordinary technological support. The pressures at deep ocean ocean depths are crushing. The darkness is total. The temperatures are near freezing. Everything about the deep ocean is hostile to human life in the most fundamental biological sense. And yet, the deep ocean covers the majority of our planet. It is the largest habitat on Earth. It is, by most measures, the least explored. Scientists estimate that approximately 95% of the deep ocean has never been directly observed by human instruments. We know more about the surface of the moon than we know about the floor of our own oceans. The creatures that live in the deep ocean are real, and they are strange. The anglerfish, with its bioluminescent lure, dangling in absolute darkness to attract prey it will never see with its eyes. The giant squid, documented to reach lengths of up to 13 meters, living in the mesopelagic zone and rarely observed alive. The barrel-eye fish, with its transparent head and tubular eyes that rotate to look directly upward through its own skull. The creatures of the deep ocean, the real, documented, photographed, scientifically verified creatures, are genuinely alien in appearance and behavior. They evolved in an environment so different from the surface world that they look like something from a science fiction film. And yet, they are real. They live in the dark water beneath us right now. This is the psychological context in which the bloop circulated online, not as an abstract data point, as a sound from a place where genuinely strange things live, a sound that no known living thing could make, a sound whose source had never been found. It is worth noting that some people who encountered the bloop online connected it to the fiction of H.P. Lovecraft, the American writer who created a mythology centered on vast, incomprehensible entities sleeping in the deep ocean. Lovecraft wrote his stories in the 1920s and 1930s, and the coordinates he assigned to the fictional sunken city of R'lyeh in his story, The Call of Cthulhu, approximately 47 degrees south, 126 degrees west, were noted by some internet users as being relatively close to the triangulated origin of the bloop. This observation spread widely online. It was, and it is important to be precise about this, an observation about a geographic coincidence between a real event and a fictional story written decades before the event occurred. Lovecraft invented his coordinates. The bloop's coordinates were calculated from real acoustic data. The proximity is a coincidence with no scientific significance. The connection was an internet curiosity, not a scientific theory, and no credible scientist or scientific institution treated it as anything other than that. The bloop remained in the category of genuinely unexplained for years, and then, gradually, the explanation began to come together. The key was ice. Antarctica is the coldest continent on Earth. Its ice sheet, the largest single mass of ice on the planet, contains approximately 26.5 million cubic kilometers of frozen water. Around its edges, where the ice sheet meets the ocean, enormous structures called ice shelves extend out over the water, floating on the ocean surface while still connected to the continental ice sheet behind them. These ice shelves calve, periodically breaking off enormous chunks of ice that become icebergs and drift northward into the Southern Ocean. Antarctic icebergs are not the kind of icebergs that sank the Titanic. Those were Arctic icebergs, relatively modest in scale. Antarctic icebergs are in an entirely different category of scale. Some of them are genuinely massive by any measure. Iceberg B-15, which calved from the Ross Ice Shelf in 2000, was approximately 295 kilometers long and 37 kilometers wide, with a total area of around 11,000 square kilometers. That is roughly the size of the island of Jamaica, a single piece of ice the size of an island. These objects are not static. They move, driven by ocean currents and wind. Antarctic icebergs drift through the Southern Ocean over periods of years or decades before eventually melting in warmer waters. And as they move, as they melt, as they encounter underwater terrain, as the internal stresses of their enormous mass shift and change with temperature and pressure, they produce sound, a lot of sound. When a massive Antarctic iceberg strikes the ocean floor, or when internal fractures propagate through its bulk, or when sections of it calve and collapse, the acoustic energy released is enormous. These events are called cryoseisms, or icequakes, and they produce low-frequency acoustic signals that travel through the SOFAR channel with the same efficiency as any other low-frequency ocean sound. NOAA scientists, as they accumulated more data from the SOSIS network over the years following 1997, began to identify a category of sounds that were clearly associated with Antarctic ice activity. The acoustic signatures of icequakes have specific characteristics. They tend to show frequency variation over time as the fracture propagates through the ice. They can last for extended periods as the event unfolds. They can be extraordinarily energetic energetic because the masses involved are so large. In 2005, NOAA scientists published research that identified icequakes as the source of several previously unexplained acoustic phenomena in the Southern Ocean. The analysis of icequake acoustics continued to develop over the following years. By 2012, NOAA was ready to make a formal statement about the bloop specifically. The official NOAA conclusion, published in 2012 and available in NOAA's own documentation of unidentified acoustic phenomena, was that the bloop was consistent with the acoustic signature of a cryoseism, an icequake generated by a massive Antarctic iceberg. The triangulated coordinates of the bloop, near 50 degrees south, 100 degrees west, place the source within approximately 1,500 kilometers of the Antarctic ice shelf. This is well within the range of major Antarctic icebergs, which are known to drift to those latitudes. The energy output required to generate a signal detectable across the distances at which the bloop was recorded, which had seemed so impossible when the sound was first detected, is consistent with the kind of energy released by a major icequake event in a very large iceberg. The acoustic profile of the bloop, its frequency, characteristics, its duration, its shape, is consistent with what is now known about how icequakes sound. This is the verified scientific explanation. It is not a theory in the sense of an educated guess. It is a conclusion supported by accumulated acoustic data, by the study of Antarctic ice dynamics, by the documented acoustic signatures of known icequake events, and by the geographic and temporal context of the original detection. Since 2012, the SOSUS network has continued to detect sounds from Antarctic ice activity. The library of documented icequake acoustics has grown substantially. The patterns are consistent and repeatable. The connection between large-scale Antarctic ice events and the kind of low-frequency, high-energy acoustic signals that the SOSUS network detects is now well established in the scientific literature. The bloop, the sound that stumped scientists for years, that circulated across the early internet as evidence of something vast and unknown in the deep ocean, was ice. Specifically, it was most probably a very large Antarctic iceberg, fracturing and grinding against the ocean floor, or undergoing a major internal collapse event. The explanation is, in some ways, more interesting than the mystery, because what the bloop actually tells us, when understood correctly, is not that there is something unknown and vast in the deep ocean. It is that the processes happening at the edges of the Antarctic continent are so energetic, on such an enormous scale, that they produce acoustic events detectable across an entire ocean basin. A piece of ice the size of a small country fracturing under its own weight, and the pressure of the water around it releases energy comparable to a significant seismic event, and that energy travels through the SOFAR channel and arrives hours later at hydrophones thousands of miles away as a clear, distinct signal. The scale of what happens at the edges of Antarctica on a routine basis is itself extraordinary. Icebergs that dwarf cities, ice shelves that have existed for thousands of years, collapsing over periods of decades, processes driven by the physics of a planet cooling unevenly, by ocean currents carrying warmth toward polar regions, by the interaction of ice and water and rock on a scale that makes human engineering look microscopic. The bloop is a data point from those processes, a single acoustic event, one of many that the SOSUS network detects from Antarctic ice activity every year, that happen to be loud enough and to occur in the right location relative to the hydrophone array, to register unusually clearly and to be noticed and named and to enter public consciousness as a mystery. It is resolved now, but the resolution does not make the deep ocean any less vast or any less unknown. The 95% of the deep ocean that remains unexplored is still unexplored. The creatures that live in the deepest trenches are still largely unknown. The Hadal Zone, the deepest layer of the ocean, below 6,000 meters in the great trenches like the Mariana, the Tonga, the Philippine, is accessible only with the most advanced deep-sea vehicles and has been directly observed at only a tiny fraction of its total area. What lives there is genuinely not fully known. New species are discovered in the deep ocean every year. Some of them are deeply strange. Some of them are large. The giant squid, whose existence was doubted by scientists well into the 20th century, turned out to be real and to reach lengths that had seemed impossible. The colossal squid, understood, even larger and less studied, lives in Antarctic waters and is known primarily from specimens found in the stomachs of sperm whales. There is no reason to believe that the catalog of deep ocean life is anywhere near complete. The ocean is large enough and deep enough and dark enough to contain things we have not yet found. That is not a supernatural claim. It is a straightforward statement about the limits of current knowledge. We have not looked at most of the deep ocean. We cannot say with confidence what is and is not there. The bloop was ice, but the question of what else exists in the deep ocean, the question that the bloop briefly seemed to answer in the most dramatic possible way, remains genuinely open, not because of anything mysterious or unexplained, simply because the ocean is very large and human instruments are very limited, and the work of deep ocean exploration is ongoing and unfinished and will be for generations. NOAA continues to monitor the hydrophone network. Sounds are still being catalogued. New acoustic phenomena are still being detected and analyzed and eventually explained or left in the pending category. The ocean continues to produce sounds that travel through the SOFAR channel and arrive at the network's sensors. Most of them are identifiable immediately. Some require analysis. A few take years to explain. That is the nature of science operating at the edge of what is known. The bloop entered the pending category in 1997. It moved to the explained category in 2012. The explanation is solid. The ice that made it has long since melted and dispersed. The energy of that fracture event, the sound wave that crossed the Pacific and registered on instruments built to track nuclear submarines, has dissipated into the ocean. Nothing remains of it except the recording and the story of why it matters. It matters because it is a window into the scale of the processes happening at the edges of our polar regions. It matters because it demonstrates how a classified military system built for one purpose can, when repurposed, reveal entirely unexpected information about the natural world. It matters because the chain of events from Cold War submarine tracking to Antarctic ice acoustics to public mystery to scientific resolution is itself a story about how knowledge develops, how questions get asked, how answers are found, and how the process is almost never as straightforward as it looks in retrospect. And it matters because the deep ocean remains the largest and least understood environment on our planet. The bloop is resolved. The mystery around it is not. The ocean is still out there, still dark, still largely unexplored, still producing sounds that travel through the SOFAR channel to listening stations that were built to hear something else entirely. If you stayed with this story to the end, thank you for watching MrPhantom. Subscribe if you want more stories like this one. Real stories, verified facts, no invention, no exaggeration, just the truth told as directly and completely as possible. Like this video if the deep ocean stayed with you after the explanation. And the next video on your screen right now is waiting for you. It is another story about something that was detected when it should not have been detectable. That produced a reaction out of proportion to what the data alone would suggest. And that turned out, on investigation, to be both more explainable and more unsettling than the mystery version. True stories only. MrPhantom.